This video is part one of two videos in which we'll learn about decimals and the operations with decimals. The concepts and procedures introduced in this first decimals video will be extended to division and order of operations in the second video. There are many places we see decimals in our daily life. Perhaps the most common place we see them is with money and measurements. These are all examples of numbers represented with decimals. All these numbers have a decimal point. The digits to the left of the decimal point are the whole number part, and the digits to the right are the decimal or fractional part. They indicate a part of the number that is less than one whole. The value of each digit is determined by its place in the number, so we call this its place value. The first place to the left of the decimal point is the ones. The next place is the tens. The value of the ones is related to the value of the tens by dividing by 10. As we go to the right, we continue this relationship to get tenths, hundredths, and thousands. Note that decimal places to the right of a number actually indicate that their value is 0. We name decimal numbers by first stating the whole number. We say "and" to refer to the decimal point. Then we name the decimal part by its smallest place value, in this case, hundredths. We may also refer to this number as 14.99, and in common speech, we say 14.99. Here are two other numbers. How would you name them? Using place value naming, the first number is called 1 and 299 thousandths. The second number is named 18 and 5 tenths. Because we can use zeros to represent smaller decimal places, we could also name this number using 50 hundredths or 500 thousandths. Let's explore what a visual representation looks like for decimals. The first number is 3 tenths, so we can represent it as a fraction, counting 3 parts from a whole divided into 10 equal parts. For 16 hundredths, the whole has been divided into 100 equal parts, and we are counting 16 of them. These representations can be helpful as we begin to explore operations with decimals. In grade 7, students use all 4 operations with decimals. And they also use combinations of operations. But let's first explore multiplying decimals. To begin, let's use a whole number product to identify some meanings of multiplication. One meaning of 6 times 4 is 6 groups of 4, which means we have 6 groups into which we can place 4 counters each. This has a similar meaning as expressing the product as a repeated addition of 6 fours. Altogether, the product is 24. So what about 6 times 4 tenths? What do you think this product is? In this case, we have 6 groups of 4 tenths. So we can place 4 tenths into each group. Combining all of these tenths, we see that we have 2 wholes and a remaining 4 tenths. So altogether, our answer is 2 and 4 tenths. Let's compare and connect these two products. In both cases, we can count 24. But on the left, we are counting 24 ones. On the right, we are counting 24 tenths. Another way we can look at 6 times 4 is with an array, which in this case is an arrangement in 4 rows and 6 columns. We can also convert this array into a rectangle. This is called an area model because its area represents the product of the dimensions 6 and 4. For 6 tenths times 4 tenths, it's difficult to make sense of what 6 tenths of a group would mean. So let's apply an area model to make sense of this product. We use a hundredths grid so that we can make tenths in each dimension. we need the dimensions to be 6/10 and 4/10. The area that represents the product is shown. We can see that it shows 24 squares filled in out of 100, so it is 24 hundredths. Once again, we see 24 in both products, but in one case it is 24 ones, and in the other it is 24 hundredths. If our decimal numbers have 2 digits, then once again it is helpful to think of 2-digit whole numbers first. Let's use an area model. 23 and 16 are the dimensions. It is helpful to split up or partition these numbers into parts that are easier to multiply. The first area is 20 by 10, which is 200. The next area is 3 by 10, or 30. Third area is 20 by 6, which is 120. And the final area is 3 by 6, which is 18. Altogether, the total area adds up to 368. This area model with whole numbers can help us make sense of multiplying decimals. How could the product of 23 and 16 help us to figure out 2 and 3/10 multiplied by 1 and 6/10? Let's partition these numbers into parts which are easier to multiply. One way of doing this is to use place value. The 2 by 1 area is 2. 3/10 multiplied by 1 is 3/10. 2 times 6/10 is 12/10, or 1 and 2/10. And finally, 3/10 times 6/10 is 18 hundredths. The total area, which is the product, is therefore 3 and 68 hundredths. Let's model this process using just numbers. We call this solving symbolically. First, we partition the numbers. The 2 is multiplied both by 1 and by 6/10. Then the 3/10 is multiplied both by 1 and 6/10. In the standard algorithm, this plays out in reverse order. The 6/10 is first multiplied by 3/10, and then it is multiplied by 2. Next, the 1 is first multiplied by 3/10, and finally the 1 is multiplied by 2. Adding them together gives us the sum of 3 and 68 hundredths. Rather than multiplying the decimal numbers directly, we can instead multiply the whole numbers and then place the decimal point using estimation. 23 times 16 is 368, which if we wrote a decimal point would come at the end of the number. But a decimal answer may place the decimal point here, or here, or here. In order to decide which one of these is correct, we can estimate. 2 and 3/10 is close to 2, and 1 and 6/10 is close to 1 1/2. So we estimate the product to be about 3. So the correct answer must be 3 and 68 hundredths. Let's apply what we have learned about multiplying decimals to a problem. A small picture frame has the inside dimensions as shown. What is the area of a picture that could be put in the frame? How could you solve this problem? As we saw with the area model, the area of the rectangle is base times height, which is 7 and 3/10 by 5 and 2/10 inches. As before, we can partition the numbers to make the parts easier to multiply. Multiply each dimension to get each area. Adding these together gives us a total area of 37 and 96 hundredths square inches. Alternatively, we could ignore the decimal places at first and multiply the whole numbers. Now, placing the decimal points, we can estimate that the product is about 7 times 5, which is 35. So the appropriate place for the decimal place makes the answer to be 37 and 96 hundredths. Note that if the problem had more decimal places, then it is appropriate to use a calculator instead. This video addresses several learning standards in the Mathematics Grade 7 curriculum. Throughout the video, we use decimals to represent and describe parts and wholes of numbers. We also extended multiplication of whole numbers to make sense of multiplying decimals. In this content standard, we focused on multiplying decimals. As your child learns about multiplying decimals in their classroom, several curricular competencies may emerge. For example, we represented decimal numbers and multiplying decimals at first using pictorial forms, and then symbolic. For each question, we explored multiple strategies to solve each problem. And finally, estimation was one of those key strategies. We hope that you found this video valuable in helping you support your child in their learning about multiplying decimals. Please watch Part 2 to learn more about extending the ideas discussed here to dividing decimals and doing order of operations. Also be sure to check out the other titles in this series.